First we start recording, then I share the screen. Okay, now you can you can see the board here. Okay, now we'll begin. We'll first do. Okay. What I propose to do today. It's better I write it down. First, we will do. First thing is, sorry, what is this? Okay. We'll do Euler's method. This is the numerical method for solving differential equation. Okay, first. Then are you thorough with eigenvectors?
I actually did this, yes, but I don't remember just now.
Okay, we will refresh eigenvectors.
I knew this properly.
We will refresh. Then we will do numerical methods for solving coupled differential equations. Numerical method. Except eigenvectors, everything is there in the roadmap.
Okay.
Numerical methods for solving coupled.
So this eigenvector comes from calculus only?
And then it's matrices.
I mean, also in calculus it comes.
You will use it in this, no, for this problem, for this topic, numerical methods, you will need this. Okay.
Okay.
This is actually, what is known as the predator prey model.
Okay.
Now, typically, suppose in marketing, you have a brand. Suppose you've got Surf or Colgate. Now, Colgate is a market leader, or Surf is a market leader. Let us just say. Now, there enters another brand, which is directly challenging Surf. So now the other brand is the predator. It is
Correct.
preying on the market share of Surf. So what will be the long-term market share of Surf vis-a-vis the other brand? Like we all saw this, in mid-90s. In Mumbai, we had Thumbs Up, the leading brand.
Right.
Okay, and
The
then
thumbs up is still nobody can beat thumbs up. Come on,
but then they
thumbs up
got,
is thumbs
but
up.
then those people, they got scared when Coca-Cola came into the market.
True.
Those people got so scared they sold off to Coca-Cola.
Okay.
Thumbs Up is made by Parle G. Parle G sold off its brand to Coca-Cola. But you said it is that. Okay. So numerical methods for solving coupled differential equation, and we will do what is that term? Okay. We will do Euler's method once again for solving coupled differential equation. Now, if you notice, we are solving differential equation using two methods. Okay. If you see this, so this is the exact method. This gives you exact solution.
Okay.
And Euler's method will give you approximate solution.
Okay.
It cannot give you exact solution. Okay? Understood? So now what we will do is we'll first solve a question of Euler's method. So if you can finish these four, then I'm very happy. There'll be one small thing remaining, face portrait, that we can do on Wednesday and we can finish off.
Done.
If we
Okay.
do this, then I'm really happy. So we really have to fight.
Okay.
So Euler's method now, it is It is here. Euler's method. Idhar gap. Euler's method. No? So let's take a question. This one. This one.
Okay.
This is one.
Mm-hmm.
Did we do this last time? No.
So which one, sir? 7?
Uh,
So 7 we did. Yes, we did.
we did 7? Okay.
Yes, sir.
Then
we did
we
7.
will not do 7 then. Okay.
Achha, okay.
Did we? Are you sure we completed the question 7?
Sir, 100%, 100%. Like very fast, but we did.
Achha, okay. So what we will do is, we'll do question number 16.
Mm-hmm.
This is nice. It's paper 2, 5 and 7, 12. 16 mark question. We'll do it.
Mm-hmm.
Okay, this is okay. Chalo. Nice question. These questions, these are the toughest questions, Of all IB, no other IB resource will give you these questions. Most of the resources, the questions they give are not good enough. Oxford gives really good questions.
Okay.
Yeah. Okay, see what we will do, the A, B, C, D, solve the differential equation, find the. See, these two we can do straight away. Now we will do, use Euler's method with the step size of.
So I'll read.
0.25, sorry.
Okay. 0.25.
Okay. The steps are 0.25. It
I
can
thought you
happen.
stopped for me to read.
Okay. To find an approximate. Okay. We are given y1. We have to find the value of y2. Okay. See, do you notice one thing? This is a 16 mark question. 5 plus 7, 12, plus 2, 14, plus 2, 16. Okay. Now, let us suppose, okay, for the sake of argument, you don't know Euler's method, suppose. But then you know this method, you know B and C. So out of 16, at least 9 marks you can get. No?
Okay.
So therefore never give up.
Then, okay.
Even if I don't know this, like right now I have not taught you this. So you don't know this. But you know this, you can still get 9 marks.
True. Correct. Okay.
So always remember this. Okay, now. Okay. Use Euler's method with a step size of 0.25 to find an approximation for y2. Okay. I want to find the value of y when x is 2. Okay. Correct, no? y1 is value of y when x is 1. Now see, if I suppose I have got my. Suppose this is my plot. I don't know what the plot is. Now, see, we are given this condition, y1 is 2. It means when x is 1, when x equal to 1, y equal to 2. Okay? It means that? Okay. Now,
correct.
So let's say we start from here. X equal to 1, y equal to 2. Okay. Now I have drawn the curve, but I don't have the curve. You understand?
Correct.
Because I have dy by dx. I don't know why. See, then my curve is y. Okay, y equal to f of x. I don't have f of x. I have f dash x. See, my curve is y equal to f of x. In the problem, I'm given y dash dy by dx
Correct, huh?
equal to y dash equal to f dash x. Let us say f dash x is gx for the sake of
Dash
argument.
SGX, okay. Mm-hmm.
So this I don't know. I don't know this. I do not know.
Mm-hmm.
No, if I know what is y equal to fx, then what's the point? Yeah, then why should I do all these things? No?
Right.
I don't know, because see, there will be questions which you cannot integrate. Like you said, integration is more difficult than differentiation. It's possible. No?
Mm-hmm.
So, but then okay, just for the sake of argument, I am showing. Suppose the curve is this. Now I will draw a tangent here. But how are you feeling?
So I'm perfect. I was just a bit sick like few days, not few days, like or 2 days back also, but now I'm fine.
See, actually, what happens, na, because of these circumstances, no, even if you have a
Uh-huh.
mild cough, oh my God, is it COVID?
Uh-huh.
Na?
Exactly, huh?
Like,
It's
if you're
scary. Like even if you like cough, you like shit. I get COVID or what?
that's what. See, if you're taking precaution, nothing will happen.
Huh.
Now, see, this is my x equal to 1,
Mm-hmm.
y equal to 2. Okay.
Mm-hmm.
Now when x is 1, y is 2. Okay. Huh? Now my dy by dx is 1 into 2. See, x equal to 1, y equal to 2,
Mm-hmm.
dy by dx is equal to x into y equal to 1 into 2 equal to 2. Okay.
Mm-hmm. Mm-hmm.
So what is dy by dx? dy by dx is gradient of tangent. We have seen this
Okay, huh.
before. Huh? So
Right, so
this is my tangent. I'll make it a little bigger so that it's not required. Okay. Now what I'll do is, yeah. Okay. Now see, this line L
Mm-hmm.
is tangent at point A. No? Correct, no?
Mm-hmm. Correct,
Line
huh.
L is tangent to y equal to f of x. Line
Yep.
L is tangent
Mm-hmm.
to y equal to f of x at x equal to 1,
By
which
2.
is point A is what? X equal to 1, y equal to 2.
1, 1, 2. Yep.
Now, the reality is that I don't have this curve, okay? Now, let us
Okay.
say at um, 0.25, okay? My step
Mm-hmm.
is 0.25. So, suppose I say x equal to 1.25. Huh? Now, x equal to 1, I will write here, x 1 plus 0.25. That's equal to 1.25.
Mm-hmm.
Now, let me say this is x1, y1, this is x2, okay? So, x2 is 1.25. So, x2 is here, this is x1, x1 equal to 1. Now, this is x2.
Mm-hmm.
x2 is 1.25.
Oh, yeah.
Okay, x2. And this x2 minus x1 is h.
Okay.
x2 minus x1 equal to h. and h is 0.25, correct? H is 0.2. H is called the step size. H is called the step size.
Oh,
Yeah? You're taking a step of 0.25. So h is 0.25 in this problem. Now
oh,
see, x2 is a point on the curve, right? So that point should be this. I mean y2. Y2 should be this. But I don't have the curve. So I will obtain this point y2. Okay? Which is wrong. Y2 should be this.
okay.
Am I right? X1 is a point on the curve, y1 is a point on the curve. X1, y1. So x2, y2 should be on the curve, no? Okay.
Absolutely.
The y2 is a point on the curve. But I don't know the curve. So I don't know y2. But y2 is not known. But is not known. So we use this point, we use this point, okay, to estimate y2. Okay, so this point, is called y2e. I will call it y2e. Okay,
Okay.
y2e is an estimate of y2. So y2e is an estimate of y2. Okay. Therefore, Euler's method is an approximate method. Okay.
Approximate method.
I
Okay.
told you,
Correct.
no, Euler's see,
Yes,
it's an
sir.
approximate method. It's not
Right.
exact method. Okay.
Right.
So what will be my, suppose x2, y2 is here. Look here. Y2, I'll use black. Y2 is here. Y2 is here. So this is the error. Okay, error. Have you understood the concept?
Yes, sir.
Huh? Have you have understood the concept?
Yes, sir.
Okay, very good. Now see, what we will, this is my point B. Okay, let's say point B is this. It should be this, but I'm only estimating. Point B should be on the curve, so I'll see this. Now see.
Okay.
Now I know that the gradient of the tangent is 2. Okay, 1 into 2 is 2, right?
Right.
You now see, now y2e minus y1, y2e minus y1, okay, upon,
that's the formula, right, sir?
that's the formula for gradient, is equal to dy by dx. At x1, y1, okay? This tangent is drawn at x1, y1. Do you understand?
Okay. Yes, sir.
Okay, at x1, y1. Okay. Have you understood, or should I explain further?
Sir, I have.
Okay, sure. So see, x2 minus x1 is called h. So y2e
Okay.
minus y1 upon h is equal to dy by dx at x1, y1. Okay?
Okay.
So my y2e is equal to y1 okay? Okay, y2e will be this. Similarly, y3e, the third point, okay, will be y2 plus h dy by dx.
So just one step. Why is there x2 minus x1 h?
That's the step size, no? x2, see, x1 is this.
Oh,
x2 is
right.
step size.
Acha, got it.
Okay. Now y3 is y2 plus h times dy by dx at x2 y2. Okay. Then y4e will be y3 plus h times
dy by dx x3 y3. So what was the question again?
1 second, right? And so on.
Okay.
So if you go for the nth term, y ne is equal to y n minus 1 plus h dy by dx at
Correct. Okay. Y minus 1.
again y n plus 1 e is yn plus h dy by dx okay. Have you understood?
Yes, sir.
Sure. Okay.
Yep.
Now see, now see, now we'll find y2. No, we cannot find y2. We got x2. X2 is so much. Now we want to find y2e. Is how much? So y2e is y1. Y2e is
y1. Okay.
y1 plus h dy by dx
x1 minus y1.
x1 y1.
y1.
Now see, what is y1? Y1 is 2.
Right.
Okay.
Acha, okay. Plus.
Right? H is 0.25.
dy by dx.
Dy by dx at x1 y1, okay, is 2.
Is 2, yep. So 2.
Okay. So that will be 2.5.
It will be, yep, 2.5.
So my y2e is 2.5. Okay.
Oh, in this way you can solve every step.
Okay.
Acha, okay.
And x2 is how much? X2 is 1.25.
1.25.
Now you want to go on till you want to find
4.
No, x equal to 2, no?
Acha, sorry.
y2,
2.
y2
Okay.
what? Now see, we got 1.25. Now we will say no x3 equal to equal to 1.25 plus 0.25, which is 1.5. Okay, x3. Now we want to find y3. Y3 is equal to y2 plus h dy by dx okay. So what is y2? Y2 is 2.5. We don't know y2, we know y2e. It's 2.5
right. 2.5.
plus 0.25. Now dy by dx when x2 y2. Dy by dx is xy, no? So x2 into y2. What is x2?
X2 is 1.25. No. Sorry. X2 is
1.25, yes, 1.25.
1.25. Right. 1.25 is to y2.
Somebody has come.
No, sir. My phone something message maybe.
And what is what?
I'll mute it. Sorry.
X2 and y2 is how much? Y2 was 2.5. No?
Y 2.5.
So how much is this now? Can you do it for me?
2.5, 0.5, 2.75.
3 point. It's multiply, not addition.
Sorry.
It's 3.7.
2.75, 0.75 into 1.25 into 1.25 into 2.5. Okay. So it's 8.59.
No. It can't be so much. 2.5 into 3.75. No, I don't think so. Where is my calculator?
2.75 into 1.25 into 2.5.
Into 0.25. H is 0.25.
Oh.
H is 0.25, no?
So, but we
Yeah.
got 2.5 there, no?
Where? No.
So, underneath.
One second. It is 0.25.
Okay.
No? 0.25.
So, 2.5 plus 0.25, 2.75
It's multiplied.
into multiplied by 1.25
No, sir.
multiplied by
All this.
that's
Okay, now.
Okay.
See, because
I got it.
y2 is 2.5, no? Okay.
Correct.
So
0.5
0.25 into 1.2.
1.25 into 2.5. This into this plus 2.5. It's 3.28.
Yeah, that's better. No, 1.25 into 2.5 is 3.125 into 0.25. So my answer is 0.78 plus
Plus 2.
2.5. That's
So
2.5.
3.28.
That's 2.5.
2.5. So
See, no,
3.28.
don't approximate. Right, 3.2812. Okay, right, go till 4 days. Don't approximate yet.
Okay.
So
Okay.
3.2812 or 3.2813. That's y 3e. Now we take x4. What is x4 now?
Right,
What is x4?
X4 is what's it, sir?
You tell me.
Oh, it's the same thing only, no?
X4 is x3 plus h. See,
x3 plus h.
x is increasing by 0.25. So 1.5
Sorry.
plus 0.25. That is 1.75.
1.75.
Okay, x4 is this. So x4 is 1.75. So now we have to find y4e. Now, can you find y4e? Write the formula for y4e.
So I have to go. So can you go up once and just up? I can see the last formula and um. So same thing. Y2. Y2. So for this case, it will be y3 plus h of your this thing dy dx and x2 y2.
x3 y3.
Sorry, x3.
Okay. Okay. That will be y3 plus h dy by dx Okay. What is y3?
Y3 is 3.28.
2813.
Hmm.
H is how much?
0.25. Dy dx
Is how much?
is multiply. So um this will be x4 into
x3
no
y3.
x3 into y3.
Uh,
x3 is
uh,
x3 is 1.5 into this
uh,
thing. I'm doing 1.5
into so
into y3,
3.281.
which is 3.281, which is 4.9215.
No,
No,
I don't get
1.5 into
1.5
1.5
into
full thing into
3.2813 into
that other included into 0.2.
0.25.
Hmm.
1.23.
I mean that it into either into 0.25
Okay.
into
1.2305. Okay. Plus
0.25.
plus
Correct.
3.2813. No?
Uh-huh.
That's 4.5118.
Correct.
4.5118.
Right. Mm-hmm.
That's y4e. Now you want to go on till x equal to 2. No? You have to take one more thing. So x is 1.75. You want to go on till x equal to 2. You see this? Till x equal to 2. So 1, 1.25, 1.5, 1.75, and 2. Right?
Mm-hmm.
Okay. So x5 is equal to how much?
So same thing as last. So
Which is x,
just yeah, x4 into plus h.
which is
Your x4 was so don't remember 1.75, right?
1.75.
Plus 0.5 plus 0
Point
1
two.
plus 0 1 plus 0.25.
That is
So 1
2.
2. So it is 2.
So we will stop here. Okay, x5 is 2. Now you find
Huh, huh.
y5 and we can stop. Huh?
Okay.
What is y5e?
So y5 will be same thing. So first x I'll have to put 2
Mm-hmm.
2 plus 2 plus bracket 2 plus
Why
bracket
2?
h.
Why 2?
Acha, by sorry 4.5 4.5118
Uh,
plus h, which is 0.25, multiplied by x into y. So 2 into
nope.
not 2
4.511.
last way,
1 point
4.5118
into
multiplied by the other one, x value is
1.7, 1.75, no?
1.75, right? Just minus it. That's the thing, and I'm finding it out. 1 second. Um, 0.25 into 4.5118 multiplied by 1.75 this plus 4.5118. It's 6.4857. This is 6.486. I just rounded off
Now
to.
we can write till three significant figures. We can
Okay,
have
okay.
6.49.
Okay.
So my y5e is, okay,
Mm-hmm.
this is my y2. Okay.
Mm-hmm.
Why? Because x is equal to 2, no?
Mm-hmm.
Huh? Have you understood this?
Yes, sir, yes, sir.
This is called Euler's numerical method
Oilers.
for solving differential equation. It
It's
is
too
not exact
long.
method. Okay. Now see.
Mm.
Now can you now let us solve this equation using the um,
Different.
let's find the exact solution now. Okay. Can you find the exact solution? Part
Yes,
B.
so for XY, right?
Uh, we are given d. This is. Have you understood this? Huh?
Yes, sir, yes, sir.
We wanted to
I've
find the
understood.
value of y when x is 2.
Correct.
Find y2. Okay.
Y is to 5.
So now,
So
now we
up till Y gets to, we have to keep on doing.
so we got it, no? This
We
is the
got.
answer. Y2 means value of y when x is 2. So this we've already got it.
Right,
Now I'm doing part B. You
Just
want to
normal
find,
differentiation.
how will you do it? You are told
I
dy
mean,
by dx.
equal to XY of only XY, na?
So
So, of X into of derivative of Y. So it will be
no,
1 into.
nil ka. Okay. You are given dy by dx. Now I want see what are
Acha,
you
I'm solving. I'm not doing differentiation.
what are you
Acha,
doing?
I'm
You
just
want to
solving.
you want to find y.
Acha, acha, acha.
I mean
Right, right,
numerically
right.
we found out y. Okay, y
Hmm.
is 3 point what 6.49. That we have done numerical. Okay, value. I want you to do it analytically.
Okay,
Find the
okay.
value of y. Okay, y equal to how much? How will you do this?
I mean, just y will be dy by dx. I mean, that which is given as y to that divided by x.
No, dy by dx is xy. Differential equation, my friend. dy by
So I
dx
don't
is
actually
xy.
remember. Last only we did. I actually don't remember.
No, we did before that. Last time
No,
we
sir, we
solved
did
that.
last day.
Okay, last time, chalo, koi baat nahi.
Uh,
Okay, now say dy by dx is xy. So therefore, we will separate the variables. dy by y is equal to dx is equal to x dx.
right.
Okay, this is called separating the variables.
Okay.
Now we integrate both sides. So what do we get? Dy upon y is what? Ln y
Uh.
is equal to integral x.
1. Oh, you know,
Now
integrate x. Sorry. X square by 2.
x square by 2 plus c.
Hmm.
So therefore ln y is this. Ln y means log y to the base z.
Base.
So therefore E is equal to, sorry,
Y.
no, y. Y is equal to E raised to x square upon 2 plus c. Correct?
Mm-hmm.
Remember this?
Yes, sir.
Sure?
Uh-huh.
Okay. So
We the last day only you explained this
y
part.
equal to E raised to x square upon 2 plus c. Now we don't know the value of c, right? But we
No.
know, what do we know? That y1 is equal to 2. We know it, okay?
Mm-hmm.
So we know that when we know that when
When y is when x is 1, then y is 2.
so now can you solve it? Okay.
Uh, I'll do it, sir.
Okay. Just 1 second. Before you, can I write this thing as e raised to x square upon 2 into e raised to c. Correct, no? So that is equal to, let a, no, c is a constant.
Right.
So e raised to c is also a constant. That's equal to k times e raised to x square upon 2.
Okay.
Now can we find the value of k? When x is 1, y is 2, right? So what will you do?
Basically, I'm just solve now. So
2
equals to k e to the power half square.
half, correct, no?
Mm-hmm.
Okay. Now what is now can you find the value of k? Thank you. Can you find the value of k now?
हाँ sir, do.
Thank you. Thank you.
So 1.213.
213. Okay, let me just check 2
Yeah,
divided
this is it 2 divided by e to the power 0.5.
1.213. Thank you. Thank you. 1.213. So 1.213. So k is equal to 1.213. 1.213. That's correct. Huh? So I put the value back. So my equation is y equal to 1.213
e to the power half.
That's my solution. Okay.
Yep.
I've answered part B. Now can I find the exact value of y2?
Of course.
What will I do?
I'm just put 2.
X
put 2 instead of...
This is x, not 2.
Yes.
Okay. Put x
now
equal
just
to 2.
put 2 instead of the x.
So what
so
do
I'll do it.
Do it.
E to the power 1 is e to the power 1.213. So 3.297.
3.297. 1 second. 1 into E. 3.30. So that's a huge error. Okay. Y equal to I think we made a mistake in these calculations because it can't be, the error can't be so much.
So can't we check the answer?
You can check it. I mean, that's okay. You can do it later. Oh, the answer. We can check the answer. Why not? This is what, where am I? I'm here. Okay. 16, page 2. No? Problem 16. This is okay. 11. But you can't depend on these answers, huh? These answers
might be
are
wrong sometimes.
Okay. Question number 16. We got these values. Right.
Correct. Full all right.
We got the values correct. I think then we made a mistake here. It means 2 point.
No, but 1.21.
This is correct. You see, this is correct.
The part B is also correct.
Part B is what 1.21. e raised to x square upon 2.
Oh, I think that is नहीं, same thing.
एक ही बात है.
Half x square, हाँ.
अच्छा, 1 second. Let us see what it says. No. We made an error in substituting. 529. We made a mistake in substituting. Na? See,
अच्छा.
where is it gone? This one. Na? Find the value of y2. Na? So therefore, we made a mistake. Na? It is e raised to x square upon 2. Na? See, y
Oh, yes, correct,
e
हाँ.
raised to x square upon 2. किधर गया?
अच्छा, हाँ, okay. Do the need to buffer.
हाँ, okay. So x square, not x.
So 2, हाँ.
E
So
raised
the
to 2.
answer will be, I'm telling you, answer will be into e to the power 2.
हाँ.
E to the power 2. It's 8.96.
That's okay. 8.96. Na? That's the exact value, correct.
Okay.
8.96.
96.
So the error is how much? Error is 8.96 minus 6.49 upon 8.96. Na?
This is the formula, no?
Ah.
No, I'm not the formula. Like it's normal. Like you should know.
I must actually, I should not use E. I should say error. Because E we are using for something else.
Right.
Percentage
So
error.
6.49. Where did we find out? I forgot.
We found out in the previous case.
Oh, correct.
This is what we estimated. Na?
Right.
Yes.
So now we're finding the percentage error.
Minus
Okay,
6.49 divided by 8.96. That's 27.6%. Okay, 28%. Huh? Okay. So we are right. Okay. Have you understood this?
Yes, sir.
Okay, now I think you must have understood today. Huh?
Sir. Now today I understood. Okay. Last I didn't understand that much, but today I understood.
No, because these topics, all these topics which I have listed, these are all very abstract topics. This
True.
we have done. My God, it's a real fight against time. Okay, I will first review eigenvector. I will first review this eigenvector, then we will continue. But let me just take a problem. Okay, suppose I have a matrix 3 minus 4 and 1. Okay, suppose I have a matrix 3 minus 4 and 1 minus 2. Okay. Okay. I have matrix 3 minus 4 and 1 and minus 2. Now, first of all, tell me what is the matrix?
What is a matrix?
A matrix.
I mean, in my mind, it's like a wood drawing, like two like 4 boxes, and you put stuff in it.
So basically, it is just an arrangement of numbers. It's just an arrangement, okay, of numbers or variables, anything. So a matrix is just an arrangement. Now in this arrangement, this is a matrix. I will call this matrix M.
Okay.
So matrix M, there are 2 rows, row 1, row 2. There are 2 columns, C1 and C2. Okay? So R1, R2, C1, C2. So it's a 2 by 2 matrix, 2 rows and 2 columns. Always mention the rows first, okay?
Of course.
2 rows and, sorry,
Mm-hmm.
2 rows.
2 rows, 2 columns.
Okay, so all row first, huh? So 3 minus 4, 1 and minus 2. Now see. Now, if I want to, now see, a matrix does not have any value. Remember this.
Okay.
A matrix is not a number.
Okay.
Like a determinant is a number. If I say 3 minus 4, 1 and minus 2, and if I put straight line, so it becomes determinant. Determinant n.
Determinant.
Now determinant has a
I've
number.
heard of this.
It's a number. It's a number. Okay. So I'll say 3 into minus 2. 3 into minus 2.
Oh yeah, I've done this. Yes.
Now I go here. Into 1 into minus 4. Minus. Minus 1 into minus 4. So that is minus 6. Wait. Thank you. Minus 6 plus 4.
Plus 4. So minus 2.
So a determinant is a number. A matrix is not a number. Remember this.
Okay, sir.
Okay. So this is not a number. It is just an arrangement. Like you
Okay.
arrange clothes in your rack. Or you arrange books on a bookshelf. Just an arrangement. Okay. It's a tableau.
Okay.
A presentation. It has no numerical value. That's a matrix. But this matrix has properties that are of great use to us. They simplify our task. So matrix
Okay.
M is this. Matrix M is equal to 3 minus 4, 1 and minus 2. Now I am saying let X be a matrix of variables. Capital X be matrix of variables. Now what it means is, okay, suppose I've got variables X and Y. So it is X, Y. So when I say X, I mean it is X and Y, or X, Y and Z. Correct? X. So what is the dimension of this matrix, or the order of
2
this
by
matrix?
2. I mean, not 2 by 2, but 2 by 1.
2 by 1. Okay? So X is a matrix of variables. Now suppose,
Matrix.
okay, I know, okay, if I say M into X is equal to lambda into X. If I say M into X is equal to lambda into X. Okay. Now what is lambda? Lambda is a constant. It's a number.
Right.
Lambda is a constant. Or we say it's a scalar.
Okay.
Why? Because this is a vector. Okay. A matrix is a vector. So this is not a vector, it's a scalar, it's a number.
Okay.
It can be 1, 2, 100, 200, minus 1000, 1 upon 10, minus 4 upon 10, whatever. Okay. So it's a number, scalar. So if mx is equal to lambda into x, then lambda is called an eigenvalue
Eigenvalue. Okay. Okay.
of n. Hmm? You understand?
Yes, sir. B- just because it's constant in this case.
No, lambda is always a constant.
Huh.
It's a scale. I mean, it's a number. Okay, it is not.
So it's like a formula that mx equals to
That,
lambda x.
that is how you define. If m of x,
Oh, okay.
if mx equal to lambda x, then
Then lambda is eigenvalue. Okay.
okay. Now see, I am saying mx equal to lambda x.
Mm-hmm.
Therefore, mx minus lambda x equal to 0.
Mm-hmm.
Now see, lambda is a scalar quantity. Now I cannot add or subtract because this is the matrix.
Right.
So what I do is, what is M? M is a 2 by 2 matrix.
Mm-hmm.
So I take I. I is an identity matrix. I say I is in, what is identity? It means 1. Okay.
Correct.
I is
1010 1001.
identity matrix. Now I want identity matrix of the same order, same dimension, same order as M. So therefore it will be a 2 by 2 matrix.
Mm-hmm.
I will be 2 by 2, which is 1. Now I is the identity matrix, right? So I can, so lambda x I can write as lambda into I
Mm-hmm.
x.
Lambda inverse. Okay.
Mx equal to 0.
Mm-hmm.
Okay. So therefore, m minus lambda I into x equals 0.
Okay.
Okay.
Mm-hmm.
M minus lambda I into x equal to 0. Now see, what is m? Now see, x cannot be 0. Okay. X is the x is what? Matrix of variables. I mean, if you are saying x
Right.
equal to 0, y equal to 0, then why are we doing all this here?
Huh.
Correct, no? So
Huh.
x cannot be 0. So therefore, we will say determinant of m minus lambda I is equal to 0. Why? Because matrix cannot have any value. No? A
Right.
matrix is just an arrangement. So we
That
will
no,
say
correct, not a
determine.
value.
Now what is m minus lambda I? No, m is what? 3 minus 4 and 1 minus 2, right?
Mm-hmm.
So 3 m minus lambda I is equal to 3 minus 4 and 1 minus 3, no?
1 minus 2.
Minus 2. Minus lambda into I.
Mm-hmm.
Yeah?
Mm-hmm.
Now that is equal to 3 minus 4, 1 minus 2 minus I take this lambda inside. Lambda into 1?
Lambda.
Okay. Yeah. That is equal to 3 minus lambda minus 4 minus 0, 1 minus 0 minus 2 minus lambda. Okay. I'm just subtracting the corresponding terms. This minus this minus this. Okay. This minus this. And okay. Now see. Now I want to find determinant. Therefore, determinant of m minus lambda I is equal to determinant of 3 minus lambda minus 4, 1 minus 2 minus lambda. Okay. This is lambda. Just find this the detergent. I'll come in about 30 seconds. Just find this detergent.
Okay.
You got it?
So determinant will be determinant minus 2 minus lambda plus lambda square. I have to solve for lambda, no?
1 second. What have you done?
So minus 2.
You multiply these two first, right?
Of course, minus that. So it's minus 2.
3 minus lambda into minus 2 minus lambda.
And minus
Minus 1.
1 into minus 4.
Okay.
Just give me minus 2 plus minus 2 minus lambda.
Okay. Lambda plus 2 plus 4. That's lambda square minus lambda minus 2, correct? You got this?
Yes, sir. Yes, sir.
Now this is equal to 0, correct?
So I have to solve for lambda, no?
We've seen this, right? So you get, what's your answer?
So I'll tell then lambda will be right.
So lambda equal to 2 or lambda equal to minus 1.
Minus 2 or 1, no? No? Oh, no,
Lambda
minus 1, minus 1. Sorry, minus 1.
Lambda equal to 2, lambda equal to minus. Now see, you've got two eigenvalues. Now a 2 by 2 matrix will have a maximum of 2 distinct eigenvalues. Okay,
Okay.
a 2 by 2 matrix, a 2 by 2 matrix, a 2 by 2 matrix will have as maximum two distinct eigenvalues.
Okay.
It cannot have more than two. So 3 by 3 will have how many?
Not more than 3.
4 by 4?
Not more than 4.
10 by 10?
Say not more than 10.
Okay, remember this. Okay, now I have got two eigenvalues. Okay, so my eigenvalues are for this matrix. Either again, and this one. Okay, is this lambda 2, lambda equal to 2, lambda equal to minus 1. Now I want to find eigenvector. Now see, we take lambda equal to 2. Now for each eigenvalue, there will be an eigenvector. For each eigenvalue, there will be an eigenvector.
Right.
Lambda equal to 2. Now lambda equal to 2 means, I will go here, this one. Okay, what do I know? See, m minus lambda I into x equal to 0, correct? Okay, what is m minus lambda I? 3 minus this is that? 3 minus lambda, correct, no? Okay, so I have got 3 m 3 minus lambda minus 4 1 is this right? Correct.
Yep.
Into xy equal to 0, correct? Yeah, now I put lambda
Yes, sir.
equal to 2. I put, so I get 3 minus 2, which is 1, minus 4,
Minus 4, 1,
and minus 4
and minus.
into x into y equal to 0. Correct?
Yep.
What does this mean? It means x, when I multiply, matrix multiplication, right? I'll multiply this 1 into x minus 4 into y. So x minus 4y. Again, here I get the same thing. X minus 4y equal to 0. So x equal to 4y, or y equal to 1 upon 4 x, correct?
Yes, sir.
So my eigenvector E1, so this is lambda 1, okay? So eigenvector E1 is equal to xy is equal to, if x is 1, y is 1 upon 4.
Right.
Now I can multiply both by 4, that's okay. But I can multiply both by any number, so I'll multiply by 4. That's equal to
Okay.
4 and 1. When I multiply by 4, I get 4 here, correct? Have you understood?
Yes, sir. Yes, sir.
Okay, that's my eigenvector.
Okay.
So for eigenvalue, for lambda equal to 2, eigenvector is 4, 1.
Okay.
Okay. Now can you find eigenvector for lambda equal to -1? Let's do it.
Okay. For -1, then
For lambda equal to -1.
3 minus. So it will be 4, comma -4. Not comma, 4 -4, 1, and -3.
-1.
So it's a -1, -1.
Okay, okay.
Correct. So, will you write down or do I write down?
Write it down.
Anyway, so 4, this 4 -4, 1, and 4 -4, 1 -1. Then the same thing you did, sir. I mean, that thing into xy, and then the same thing basically.
So what do you get? If
You will get then. So actually, I'm not writing down.
write it down.
Yes. Just 1 second. Sir. So I'm getting. So my values were 4, 4, no? 4
4
minus 4,
4, 1 -1.
1 -1. And I'll do this into xy. So mine will be x minus so which one are you doing?
No, you're
Acha,
right. Go ahead. You're right. But what you're doing is correct. See, I get m minus lambda I into x equals 0. So my m minus lambda is 4 minus 4, 1 minus 1.
xy. So it's basically x minus x, x minus x.
X minus 4x minus 4y. 4x minus 4y. Equal to 0. Therefore,
I'll do 1 with 1, okay.
y equal to x.
Uh-huh.
So my eigenvector xy e2 is equal to 1, 1. X is 1, y is 1. So I've got two eigenvectors. No?
Okay.
So for lambda equal to -1, eigenvector is
1, 1.
okay. So I've got two eigenvectors. Have you understood this?
Yes, sir.
So can we do this topic now? The next one?
Sir, of course.
Huh?
So, but where is like the calculus part here?
What did I say? This is eigenvector. Now we will go to calculus.
Acha, oh, okay.
Remember, I asked you, do you know eigenvectors?
Oh, that was just 2. Oh, okay, got it.
Okay. Now we will do this, okay? Predator-prey model. Okay. How would
That
I
is
write?
exact.
Okay.
Okay.
Numerical solution for coupled differential equation. It's called predator-prey model.
Model.
Okay, well, see, what I'll do is, I will introduce the concept now. Okay, we will solve question next time. Okay.
Fair
Now,
enough.
see,
Okay.
when we are doing these, I think let me see right here only. That's better. किधर गया? Numerical solution. Not numerical solution. Sorry. Okay. Array. So much work we have done. That's great. Numerical solution. Numerical solution. For coupled differential equation. Okay. Now, what is this? Now see, I'll explain a few little terminology, and I'll explain the concept, and then so that you understand what it is.
Okay, so done.
Now see, what is the coupled equation? See, a coupled equation is when x is changing, So what you were telling me, that implicit differentiation is not there.
Not there. Okay.
No, it's not. Y is also changing. And dy by dx with respect to a third variable, suppose time. Y is also changing with respect to time.
Okay.
When we are doing this, and we are solving numerically coupled differential equation, when we say x dot means dx upon dt. Y dot means
no idea.
dy upon dt. Okay. X is changing, y is changing. X is changing with respect to, suppose, time. Y is also changing with respect to time. So x dot is dx dt. Y dot is
dy dt.
dy dt. And when I say equation, when I say x, okay. Now this is the confusing part actually. Confusing because it's so difficult to write. When I say, how should I write? If I say x, okay, I will try to write in a very decorative way. When I say x, okay, I mean matrix xy.
Okay.
No, I can't write better. Okay, you will have to understand.
It's fine, huh?
Okay, when I say matrix x, it means matrix xy. Now, when I have this, so my solution, okay. Okay. Now, if my xy if my xy is equal to some matrix M into xy. No, if my x dot y dot, okay, is equal to some matrix M into matrix X. Matrix M into matrix X, which I will write as matrix M into matrix X. Okay, which is equal to M into X into Y. Into X, not into X into Y. Okay, now I will go through it. This is a coupled differential equation is a differential equation in which x is changing with respect to a third variable t in this
Okay.
case, also changing with respect to the same third variable t. Hmm?
Okay.
We say x dot means dx by dt, y dot means dy by dt. Matrix x's, matrix a variable. X dot
Okay.
y dot is m into x, or
Okay.
which is m
Okay.
into xy.
Mm-hmm.
When this happens, now you can open your formula booklet if you like. Okay. When we solve this, we say x is equal to some constant a into e raised to lambda 1 t into p1
Okay.
plus b e raised to lambda 2t into p2.
Mm-hmm.
Now lambda 1, lambda 2, these are eigen values of n,
Mm-hmm.
matrix n. And p1, p2 are eigen vectors
Okay.
of matrix M. Now P1 corresponds to lambda 1. So P1 is associated with lambda 1. P2 is associated with lambda 2. Okay,
Mm-hmm.
this is it. So these are my variables.
Okay.
Sorry, this is my problem, my definition. There's no problem is defined. So can you go back to your differential equation? Can you, beg your pardon, can you go back to your formula booklet?
Formula booklet. Okay.
Yeah, yeah.
Going.
I put formula booklet in Google Classroom.
Sir. Sir.
This one, na? Can you see this?
Yep. 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 Yep.
So this formula is
Okay.
given to you. You don't have to.
No.
Huh? Now this is matrix X. Okay.
Okay.
So when we write X, we mean matrix X. Okay. This
Okay.
is matrix X. Matrix X.
Okay.
Huh? You will have to. I can't write better. Yeah. Huh? Huh? Is this?
Okay.
Is that
Okay.
clear?
Yes, sir.
Any doubt?
Nee.
Okay. Now I think we will continue this next time. Okay. I've
Done.
introduced
Sir.
this because I've introduced this thing, and we can just go through
Do the
it.
sums.
This is actually quite simple. You only have to substitute. Okay. This Euler's we have done, but now for coupled differential equation we'll do it. Okay. So now you will see this is exact. This is approximate.
Okay.
Because
Okay.
Euler's method is approximate.
Okay. Okay.
Okay. Is that clear?
Yes, sir.
Chalo, huh? So I think we can
Okay,
stop
sir.
now. That should be more than sufficient. Yeah?
Sir.
Okay.
Okay, then, sir. Then. Okay.
Yeah.
Then thank you, sir. And I'll see you on Wednesday. Yeah.
No, Venus, yes, correct.
Namaskar, sir. Namaskar. Bye. Good
Bye
night.
bye, bye bye, bye bye. Yeah, bye bye.